All right, gave you a little bit of time to work on that. Hopefully it went well for you, and we're going to go through a few answers here. So that first one mole of H2SO4 was 100 grams, and I want to know if that was true or false. Number two, there were 2 moles of magnesium that have a mass of 24 grams, 48 grams, or 36 grams, and you picked the right answer for 2 moles of magnesium. In number 3, I give you a balanced reaction. 6 moles of sodium plus 1 mole of nitrogen yields 2 moles of sodium nitride. If I only use 3 moles of sodium, how many moles of sodium nitride are produced? Number 4, I'm giving you boron and oxygen, and I want you to complete the reaction. And number 5, using that reaction, if I started with 22 grams of boron, how many grams of boron oxide do I actually produce? All right, so I'm going to switch over here to my iPad so that we can look at some answers together. All right, there we go. Okay, so first question was about a large molecule called H2SO4. This is sulfuric acid, very strong acid, and we have 3 different atoms in it. We have 2 hydrogens, 1 sulfur, and 4 oxygens. So we're just going to write those down. I have hydrogen, sulfur, and oxygen, and I have 2 of those, 1 of those, 4 of those. All right, now I have to go over to my periodic table, and so let's see here if I can get over there. There we go. And I'm going to look at hydrogen first. All right, I'll have to remember that 1, okay, 1.00, but I'm just going to use 1, okay, and then sulfur, right there, 32, and then oxygen right above it, and I'm going to round that to 16. So I'm going to use whole numbers. So back over to, all right, hydrogens. There was 2 of them. Each one was 1, so 1 plus 1 is 2. Sulfur was 32, and there was only 1 of them. And oxygen, there were 4 of them. All right, if I add those all up, that is going to be 64 grams. So I'm going to take that number and that number and that number. I'm going to add all those up together, and I get 98 grams for 1 mole. So in our true-false question, I said, did it equal 100? And 100 grams does not equal 98. So number 1 was false. All right, number 2. A little quicker here. 2 moles of magnesium. Well, I've got to go over to my periodic table. There's magnesium. Right there, it says 24.3, but I'm going to use 24. I'm going to round it and then go back over here. And so I have 2 moles of magnesium. So that is 2 times 24, or 48 grams. So the answer was B, 48. Right, number 3. I gave you an equation. 6 moles of sodium plus 1 mole of nitrogen produced 2 moles of sodium nitride. Okay. So in this one, what we're going to do is treat it like a recipe, because I need 6 moles of sodium over here to produce 2 moles of sodium nitride on the right. And so if I change that and I say, well, I don't have 6 in my pantry, I only have 3. So what happens then to my product? I only start with half, and so that's what I'm going to end up with. So I'm going to end up with 1 mole of sodium nitride, and that was answer B. All right, let's go on to number 4. So number 4, I needed to complete the reaction starting with boron, and I'm going to react that with oxygen, and I already told you it was diatomic. So boron comes first, it's furthest to the left, then the oxygen. Boron is +3, oxygen -2. So when I switch those numbers, boron oxide looks like that, B2O3. And then I need to balance that. And I have a 2 for oxygen on the left, 3 on the right. So I'm headed for 6 oxygens on each side. So I need a 2 and a 3, because 3 times 2 on the left is 6. 2 times 3 oxygens on the right is 6. I have 4 borons. Okay, so now in number 5, what I wanted to know is if I use 22 grams, well, 22 grams of boron. I need to go back, look at my periodic table, and when I do, I see that 1 mole of boron is 11 grams. And so 22 divided by 11, that's what I have, divided by the atomic weight, just like in our stoichiometry, is 2 moles. So if I only have 2 moles of boron to start with, well, wow, that's just like number 3, my recipe. I cut the number of moles in half from 4 down to 2. So therefore, I'm going to cut my product in half from 2 down to 1. So I'm only going to get 1 mole of boron oxide. All right, so we're going to move on to a few other calculations, and so grab a piece of paper or a new drawing in Seesaw and we'll get going.